The coolest it got in Phoenix last night was 97 degrees. The best moment of relief America's fifth largest city received in 24 hours tied the warmest night ever recorded there, a mark set 3 summers ago during the heatwave that killed 645 people in one county. The same afternoon, the airport thermometer hit 117 and broke its record. 431 weather alarms are active across the country this morning, and the dome driving all of it is still strengthening, climbing toward a measurement forecasters almost never get to write down. Everyone is asking how hot this weekend gets. That is the wrong question. The real question is how long this lasts, because that answer decides whether this summer becomes a close call or a ledger, and history has already run this exact experiment 3 times. If this has you hooked, subscribe to the Sky Lab, because we will be tracking this dome checkpoint by checkpoint until it breaks, and this story is nowhere near finished. Drop a comment telling me where you're watching from and the hottest night your town has ever put you through, because the nights are the real story here. Now, let's get into it. Part 1. The day the thermometer broke its book. At 3:14 in the afternoon on July 24th, the official thermometer at Phoenix Sky Harbor International Airport touched 117 degrees Fahrenheit. That single reading erased a record that had stood since 2023, when the same station topped out at 116 on the same calendar day. And if you want the honest answer to the question in this video's title, it starts right there, because the first thing that happens when a heat dome refuses to die down is exactly this. The records start falling, not in one place, everywhere the dome touches. Phoenix was not alone on July 24th. Yuma, Arizona reached 116 degrees. El Centro, California hit 117. Across the lower Colorado River Valley, station after station posted readings above 115. A corridor of desert running hotter than the inside of most commercial ovens set to warm. These are not estimates and they are not heat index values. These are actual air temperatures measured in the shade by instruments whose entire job is to be boring and consistent. The National Weather Service office in Phoenix has an extreme heat warning posted through 8 in the evening on Monday, and the forecast behind that warning is not shy. Highs of 110 to 118 are expected across the region day after day, and forecasters have flagged the possibility of readings near 120 as this heat dome reaches its peak strength. The warning text itself uses the phrase major heat risk for the Phoenix metro, and for the deserts along the Colorado River it escalates to major to extreme heat risk, which is the highest category the Weather Service assigns. In the language of that system, extreme means the heat is dangerous to anyone without effective cooling or hydration, not just to the vulnerable, not just the elderly, not just outdoor workers, anyone. Think about what that forecast range means for a moment. The difference between a normal brutal July day in Phoenix and the hottest day in the city's entire recorded history is now down to about 5 degrees of margin, and the warning does not expire tomorrow or the day after. It runs through Monday evening, and the offices covering the deserts have already signalled that it may need extending beyond that, because nothing behind it in the forecast looks like relief. That all-time ceiling, by the way, is 122 degrees, set on June 26, 1990. That day earned a strange kind of fame. Commercial jets were grounded at Sky Harbor, not because anything was broken, but because the aircraft performance charts pilots used to calculate takeoff simply did not extend past 120 degrees. The atmosphere had exited the paperwork. Engineers had never bothered to compute how a passenger jet behaves in air that hot, because nobody believed they would need to. Hot air is thin air. Thin air gives a wing less to push against and an engine less to breathe, and at some temperature every runway in the world becomes too short for the aircraft sitting on it. In 1990, nobody knew exactly where that temperature was for Phoenix because the tables ran out first. 36 years later, the forecast is flirting with that neighbourhood again, and this time it is not a one-afternoon spike, it is a plateau. It is worth being precise about what a daily record means at a station like Sky Harbor, because that precision is going to matter later in this video when we deal with the people who say these records are manufactured. Phoenix has been keeping continuous weather records for more than 80 years. A daily record means that out of every July 24th in that entire archive, spanning the 1940s, the 50s, the 60s, every decade of the city's explosive growth, Not one of them was as hot as this one. The comparison is the station against its own history. Same location class, same instrument standards, same time of day. When that station says this was the hottest July 24th it has ever measured, it is making a very narrow, very defensible claim. So what is doing this? The short version, and we will build the full machine piece by piece as we go, is a heat dome. A sprawling ridge of high pressure parked in the upper atmosphere over the southwestern and central United States, pressing down on the air beneath it like a lid on a pot. Air sinks under the ridge. Sinking air compresses. Compressed air warms. Clouds cannot form, so the sun works the ground unopposed, and the ground returns the favour by heating the air from below. The dome is not weather passing through. The dome is weather that has stopped moving, and the reach of this particular dome is what separates it from an ordinary southwest scorcher. As of this morning, extreme heat products stretch from the Mojave Desert to central Iowa. Alerts cover the deserts of California and Nevada, the entire Phoenix metro, huge stretches of Kansas and Nebraska, and corn country in the upper Midwest. We will walk that whole map shortly, because the scale of it is its own story. Down at street level, the numbers translate into something more human. Local reporting from the Phoenix area describes residents whose homes are holding in the high 80s indoors, with the air conditioning running flat out, unable to close the gap against what is pressing in from outside. One resident quoted in local coverage described the heat as, quote, the devil himself. Health officials are repeating the triad they repeat every time this happens, and it stays worth repeating because it keeps people alive. Drink water before you are thirsty, because thirst is a lagging indicator, and by the time it arrives you are already behind. Stay out of the midday sun when the combination of air temperature and direct radiation can push the load on your body far past what the thermometer alone suggests, and check on your neighbours, especially the ones who live alone, because in every major heat disaster of the last half-century, the people found too late were overwhelmingly people nobody was checking on. Notice something about that indoor number, though, because we are going to come back to it more than once. A home sitting at 88 degrees with the air conditioner running is not a comfort problem. It is a signal. It means the machinery that makes this city livable is already operating at the edge of its envelope, while the grid is healthy and the power is flowing. Hold that thought. Here is the thing about the question this video is asking. When people hear a title like what happens if the heat dome doesn't die down soon, most of them picture a bigger number, 120, 121, maybe the all-time record falls. And sure, that could happen, and it would lead every newscast in the country for a day. But a single scorching afternoon, even a historic one, is survivable almost by definition. You shelter, you wait, the sun goes down, the desert cools, and the city exhales. That is the deal Phoenix has always made with July. The afternoon belongs to the heat, and the night belongs to recovery. The real answer to the title, the one written in the actual mortality data from the last 30 years of American heat disasters, has very little to do with how high the thermometer climbs on the worst afternoon. It has to do with how many afternoons there are. And more than that, it has to do with what happens in the hours when the sun is not even in the sky. Because on the night of July 24th, after the cameras had their footage of the 117 and the record graphic had made the rounds, the thermometer at Sky Harbor did something quieter and much more frightening. It refused to fall. And the number it refused to fall past is, by the accounting that actually predicts who lives and who dies in events like this, the most important measurement anyone in the Southwest has taken all year. Part 2. The Night That Never Cooled. The overnight low in Phoenix, in the small hours after that record afternoon, was 97 degrees. Read that carefully, because it is not a misprint and it is not a daytime number. The single coolest moment of the entire night, the bottom of the curve, the temperature the city reached at its maximum point of recovery, was 97 degrees Fahrenheit. That ties the warmest overnight low ever recorded in Phoenix, a mark set on July 19th, 2023. The city spent roughly 3 hours below 100 degrees, between about 4:25 and 7:30 in the morning, and then the sun came up and took even that away. Sit with the shape of that day. 21 hours at or above 100 degrees, a record high in the afternoon, and a record-tying warm night behind it. both inside the same rotation of the Earth. The ceiling and the floor rising together. To understand why the floor matters more than the ceiling, you need to know what your body does with heat and when it does it. Through a brutal afternoon, a healthy human body is fighting an active battle. Your heart rate climbs. Blood vessels near the skin dilate, pushing warm blood outward so heat can radiate away. You sweat, and the evaporation pulls energy off your skin. All of that is work, real cardiovascular work, comparable to hours of light exercise, and the body can sustain it for a while. What it cannot do is sustain it indefinitely. The battle is supposed to end at night. When the air cools into the 70s or even the low 80s, your core temperature drifts down, your heart rate settles, and the physiological debt you ran up during the day gets paid off while you sleep. At 97 degrees, none of that happens. The air is still warmer than the surface of your skin, which sits around 93 to 95 degrees, which means that even at 4 in the morning, heat is still flowing into your body, not out of it. Radiation stops working in your favor. Convection stops working in your favor. You're left with sweat alone, all night long, which means your heart keeps working its daytime shift straight through the hours it was supposed to rest. And you lose water continuously through hours when almost nobody wakes up to drink. There is no payment on the debt. There is only compounding interest. The next afternoon does not start from zero. It starts from wherever the night left you, and the night left you in deficit. The warning offices know this is the mechanism that matters. The San Diego Forecast Office, in its extreme heat warning covering the desert valleys this weekend, put the sentence right into the official product. Quote, "Elevated low temperatures will limit overnight relief from the heat. That is the entire physiology lesson, compressed into 10 words of federal prose." When a forecast office goes out of its way to warn you about the lows, it is telling you the event has crossed from uncomfortable into dangerous, because the recovery window is the thing standing between a hot week and a lethal one. We have covered the mechanics of killer warm nights before on this channel, back in June when the first dome of the summer parked over the eastern half of the country, so I will not rebuild that whole case here. But the one-line version bears repeating, because it is the single most useful fact in this entire subject. In almost every mass casualty heat event in modern history, the victims were not killed by the afternoon peak. They were killed by nights that never let them recover. Chicago in July of 1995 was, at its core, a 3-night event. We will walk through that ledger properly later in this video because it is the answer key for the question we're asking. There is a reason your own experience may argue with this, and it is worth disarming now. Almost everyone has survived a brutally hot day and come away thinking of heat as unpleasant but manageable, because almost everyone's brutal day was followed by a recoverable night. Your intuition about heat was trained on a cycle that includes the reset. What a duration event does, and what makes it categorically different from the weather that built your intuition, is remove the reset while keeping everything else looking normal. Same sun, same city, same routines, minus the nightly repayment. That is why these disasters consistently surprise the places they land on. Nothing about them looks unprecedented from inside until the 3rd week. For now, just register the company that 97-degree night is keeping. The only other time Phoenix has ever recorded a low that warm was July 19th, 2023. And 2023, as we will see, was not just another hot summer. It was the deadliest heat season in the modern history of American cities. The dome of 2026 just matched the signature night of that summer on its first big weekend. The rest of the desert southwest is being fitted for the same kind of nights. The Las Vegas Forecast Office expects overnight lows of 80 to 95 degrees across the Mojave and the Colorado River Valley through the weekend, with Death Valley potentially failing to drop below the mid-90s at all. The San Diego office, covering the Coachella Valley, forecasts lows in the mid-80s to mid-90s under its extreme heat warning. These are numbers that would qualify as afternoon highs in most of the country, being posted as the coolest moment of the night. Cities make this worse, and Phoenix is a nearly perfect machine for making it worse. Concrete, asphalt, and masonry spend the day absorbing solar energy, storing it the way a brick pizza oven stores heat long after the fire is out. Then, through the night, all the hardscape releases its stored energy back into the air. The urban heat island effect means downtown Phoenix can run several degrees warmer overnight than the open desert just outside town. The city is not just enduring the dome, it is banking the dome's heat by day and paying it back into its own streets by night, right through the hours when its residents need the cooling most. The timeline of the night of July 24th makes the ratchet visible. Sunset came with the air still deep in the 100 teens. Through the late evening the temperature ground slowly downward, surrendering a degree at a time as the pavement fought back with everything it had stored since morning. It finally slipped under 100 degrees at roughly 4:25 in the morning. It held there, in the upper 90s, for about 3 hours, and by 7:30, with the sun barely clear of the horizon, the city was back into triple digits and climbing toward another shot at 117. That is the whole recovery window. 3 hours, none of them below 97. A human body, an air conditioner, and a power grid all got the same 3 hours off. Then the shift started again, which brings us back to those homes holding in the high 80s with the air conditioning running. During the day, that is uncomfortable. At night, it becomes something else. Air conditioning systems are engineered against design temperatures, assumptions about the gap between outside and inside that the machine has to overcome. A unit size to pull a home down to 75 when the outside air is 110 is being asked to do something fundamentally harder when the outside air never leaves triple digits, and the attic above the living space is still radiating like a stovetop at midnight. The machines run continuously. They shed less heat per hour than they were designed to. They age and fast forward, and every single one of them is drawing near its maximum electrical load at exactly the same time as several million of its neighbours. Forecasters know all of this, which is why, quietly, the number they watch during a long heat event is not the daily high. It is the overnight minimum. The National Weather Service issues its warnings on a metric called heat risk that weights warm nights heavily, and the Phoenix office specifically flagged, in its warning text for this event, that elevated overnight lows will limit relief. When you see a warning that says dangerously hot conditions with little overnight relief, that phrase, little overnight relief, is the forecasters telling you which record they are actually afraid of. One city's terrible night, though, is still just one city. What makes this event national is how many places are being fitted for versions of the same experience at the same time. As of this morning, the alert map of the United States looks like something is wrong with the map itself. 431 separate warnings, watches and advisories are active at once, and the number is climbing. That map is the next part of the story, because its size answers something the Phoenix numbers alone cannot. It tells you how big the machine making all of this actually is. Part 3. 431. Alarms. As of 12:27. Universal time this morning, July 25th. The National Weather Service had 431 active alerts in effect across the United States and its waters. 24 hours earlier, that number was 353. The country added 78 alarms in a single day, one of the largest one-day escalations of the summer, and it did so while the heat dome responsible was still days away from its forecast peak. Break that 431 down, and the anatomy of the event emerges. 49 of those alerts are extreme heat warnings, the most serious heat product the Weather Service issues. 90 more are heat advisories. Another 20 are extreme heat watches, which are the forecaster's way of saying the warning criteria will likely be met soon. Add those together, and 159 active products, roughly 37% of every alert in the country right now, are about heat. For comparison, the next biggest single category is routine small craft advisories scattered across coastal waters, the background noise of the marine forecast system. Behind the heat products sit 17 red flag warnings for fire weather and 16 air quality alerts, and we will get to why those two categories are not separate stories at all. The United States alert system is, at this moment, primarily a heat warning system with a fire problem attached. The trajectory matters as much as the total. Regular viewers may remember that earlier this month during the Texas flood coverage, we flagged the national alert count surging past 420 as a sign of how loaded this summer's pattern had become. It then settled back. Now it has returned to that territory and kept climbing, driven this time almost entirely by heat, and the forecast offices adding products faster than they retire them are precisely the ones sitting under the dome's forecast expansion path. Now walk the map, because the geography is the point. Start in the obvious place, the desert southwest, where the warnings blanket the Phoenix Metro, the Coachella Valley, the Mojave, Death Valley, and the Colorado River corridor with forecast highs we have already covered. Then go north and east, and things get stranger. Iowa, a state most people associate with corn and mild complaints about humidity, is carrying 34 separate alert products this morning, the most of any state in the country. The Des Moines Forecast Office has extreme heat warnings posted with heat index values of 110 to 112 expected across central and western counties, and here is a detail from those same counties that tells you how loaded the air mass is. This very morning, before the heat index climbed anywhere near those numbers, those counties were under dense fog advisories, with visibility down to a quarter mile or less. Fog at dawn and a 112-degree heat index by mid-afternoon in the same place on the same day. That is not a contradiction. It is a signature. It means the lowest layer of the atmosphere is so saturated with water vapor that it condenses into cloud the moment the overnight temperature dips, and then, once the sun burns the fog off, that same water vapor becomes the multiplier that turns a 100-degree air temperature into a 112-degree experience for a human body. The fog and the danger are the same water. Kansas is next door carrying 20 alerts of its own, and the Wichita office expects heat index values up to 113 in the south-central part of the state this afternoon. Nebraska holds 22 products, with the Omaha office forecasting indices up to 113 and running its warnings continuously into Monday morning, an unbroken multi-day stretch that includes once again those warm nights. The North Platte office, covering the Sandhills, calls today's setup dangerous heat outright, with indices up to 112 across far north-central Nebraska. In these states, the weapon is not the thermometer alone, it is the swamp air riding on top of it. A dry 105 in Phoenix and a humid 98 in eastern Nebraska can be comparably dangerous because humidity throttles the evaporation of sweat, and evaporation is most of your cooling system. The Dome's eastern march is already scheduled too. The Kansas City office expects heat indices of 100 to 110 today, climbing to 105 to 110 on Sunday. The Lincoln, Illinois office is telling central Illinois to prepare for what it calls oppressive heat Sunday and Monday, with indices between 105 and 110 both days. Chicago's forecasters expect the steamy air mass to envelop their area by early Sunday morning, with heat indices peaking near advisory criteria and dew points they describe, with the weary precision of Midwestern meteorologists, as corn-fed, because at the peak of the growing season, millions of acres of transpiring corn genuinely do pump measurable moisture into the air and push the heat index higher. Even Dallas is running a heat advisory with indices up to 109, expecting more advisories daily through midweek. Everywhere the map turns orange, the forecast a day or two out turns it darker. Then there is Denver, which deserves its own paragraph, because Denver is where this dome is reaching backward through more than a century of records. The Boulder Forecast Office wrote it plainly in this morning's discussion. Denver's record for today is 99 degrees, set in 1963 and before that in 1931. Tomorrow's record is 100, set in 1910. Both, in the office's own words, could be tied or broken. The 1910 mark is worth pausing on. When that record was set, Arizona and New Mexico were not yet states. The city measuring it was a mining boomtown of about 200,000 people, lit substantially by gas and early electric lamps. That number has survived the Dust Bowl, the 1950s, the 2000s heat waves, every summer for 116 years. The atmosphere over Colorado this weekend is being asked to beat it, and the professional forecasters who study this exact air mass for a living think it has a real chance. The office has already expanded Sunday's heat advisory to the entire northeastern plains of Colorado, where some lower elevations may reach 105. Put the whole picture together. From the Mojave Desert to central Iowa is roughly 1,500 miles, and you can drive the entire distance right now without ever leaving a county that is under an active heat product. One connected atmospheric structure is simultaneously threatening a 122-degree all-time record in Arizona, a 116-year-old record in Colorado, and heat indices in the 100 teens across the Corn Belt. Different climates, different weapons, one dome. And the breadth matters for the same reason the nights matter. Remember the frame this whole video hangs on. Duration is the variable that turns heat from weather into disaster, and breadth is duration's silent partner because breadth is what determines how many millions of people are inside the experiment while the clock runs. A dome over one desert city is a regional emergency. A dome pressing on the southwest, the Rockies, the southern plains, and the Midwest at once, for days on end, is running that experiment on a substantial fraction of the national population simultaneously. 78 new alarms in a day is the sound of the experiment enrolling new subjects. Which raises the obvious question, the one the rest of this video turns on. What exactly is holding all of this in place? Storm systems move, fronts sweep through. The normal churn of weather across North America replaces air masses every few days like clockwork. For a structure to sit still long enough to break records across 4 time zones, something in the upper atmosphere has to be genuinely unusual. This week, the forecasters measuring that something are watching a number that most summers never produce at all, and by late this coming Friday over Utah, they expect it to arrive. Part 4. The Ceiling. 600 decameters. Every weather map you have ever seen has a hidden third dimension, and that dimension is where this story is actually happening. Forecasters track the height of a particular pressure surface, the 500 millibar level, roughly the altitude where half the atmosphere's mass is below you. Over a cool air mass, that surface sits low, maybe 5,500 meters up. Over a hot one, it bulges upward, because warm air takes up more room. A column of atmosphere is like a column of mercury. Heat it, and it expands. Measure how tall it stands, and you have measured quite directly how much heat is stacked underneath. Meteorologists write those heights in decameters, units of 10 meters. A typical summer ridge over the American West might crest at 580, 590 on a strong day. Heat waves you remember get built by 590s. The great domes of recent summers, the ones with names and death tolls attached, have crested in the mid to upper 590s. 600 is the class above, a threshold that operational forecasters treat the way structural engineers treat a load rating, because so few events have ever tested it. The Weather Prediction Center's extended forecast discussion issued this morning contains the number that defines this event. The models, in good agreement, build the ridge to a potential 600 decameter high centered over Utah by late Friday. 600 decameters, 6 kilometers of atmosphere, thermally inflated until its midpoint stands nearly 200 meters taller than it would on an ordinary hot day. Numbers in that vicinity sit among the highest values ever measured over the interior West. It is the atmospheric equivalent of a flood gauge reading within inches of its all-time crest, except this gauge measures accumulated heat, and its crest is still forecast to rise. When Houston's forecast office nicknamed the structure a heat dome in its own discussion this week, it noted the ridge near 598 decameters and strengthening towards 600. The nickname is casual, the measurement is not. The same Houston discussion, incidentally, may be the most honest weather product a federal office has issued all summer. Southeast Texas, the forecasters wrote, will feel like a sizzling plate of fajitas, minus the deliciousness. Behind the joke, the numbers were bleak. Atmospheric moisture in the lowest layers dropping toward the 10th percentile, which suppresses clouds and rain. Temperatures at the 850 millibar level, the layer that caps and cooks the surface, climbing above the 90th percentile and occasionally brushing the 99th. Triple-digit air temperatures on the horizon for the coming week, heat indices of 104 to 112, and, in the office's words, not much relief during the overnight hours. There are those nights again. Same signature, 1,500 miles from Phoenix. The Weather Prediction Center's National Outlook wraps the whole structure in one sentence that deserves to be read the way it was written, as a plain statement by the people whose job is to not exaggerate. Quote, "Extreme heat will continue to make weather headlines across a large expanse of the country going into next week. Their forecast maps put widespread upper 90s and low 100s from Montana to the Dakotas, 10 to 15 degrees above average for the northern plains in late July. They hold Texas through the Gulf Coast in the mid-90s to 105 on most days, with heat indices exceeding 110 at times. They keep the 110s running through the lower deserts, and the valid period on that extended discussion runs through the first day of August. Read that timeline again. because it is the quiet headline of this entire video. The federal government's medium-range forecast does not show this dome dying down soon. It shows the dome expanding westward, strengthening toward a structural maximum and persisting into a new month. The forecast for the dome's death does not currently exist. The dome's western shoreline tells the same story. Los Angeles's forecast office describes hotter than normal conditions continuing for, in its words, the foreseeable future, with an extreme heat warning for the Antelope Valley and heat building again into next weekend. San Diego's office carries warnings for its deserts and mountains through Monday night. The Hanford office, covering the southern San Joaquin Valley, posts 108 to 112 through Monday. Even Seattle, sitting temporarily under a cool marine trough, forecasts the southwest ridge rebuilding toward the Pacific Northwest by late week, with heights climbing back through the mid-580s. The dome is not merely holding its ground, it is scheduled to annex more. The models are not in perfect lockstep, and the disagreements are worth knowing because they mark the exits. The extended discussion notes that the guidance agrees best on the ridge expanding across the west, while the biggest differences involve the trough over the east coast, where some models carve it deeper and more amplified than others. That eastern trough is the one feature on the map with any leverage over the dome. A deep enough trough can, in principle, shove the ridge westward and shave its edges. For now, the operational forecast splits the difference and keeps the dome in charge, but that model disagreement is the first genuine crack of daylight in this whole forecast, and we will come back to it at the end of the video when we talk about how this actually ends. One honest caveat belongs here, and this channel owes it to you before the dread runs any further. A forecast that extends into August is a probabilistic statement, not a prophecy. Model guidance at day 7 is good and getting better, but it is guidance, not fate, and we will spend real time at the end of this video on the specific, physical ways this pattern could break earlier than advertised. The atmosphere always holds that option. What you should take from the 600 decameter forecast is not certainty. It is that the people paid to be cautious are describing a structure near the top of its measurable range, with no exit ramp yet visible in their data. Even Seattle's forecasters, sitting under the one cool trough on the entire western map, ended their long-term discussion this morning with a parenthetical that reads like a sigh. Quote, "Is it really the last week of July?" Their own forecast answers the question. By Friday, the ridge rebuilding over the northwest pushes heights back toward the upper 580s, and the cool exception starts folding back into the continental rule. So this is the machine as it stands at midday on July 25th. A dome measured at the edge of the record book still inflating. A record afternoon and a record night already banked in Phoenix. A century-old mark in play in Denver. 431 alarms and climbing. And a duration forecast that runs past the end of the month. But a structure this large does not simply sit there radiating menace evenly in all directions. A dome this strong reorganizes everything around it. It decides where the rain is allowed to fall and where it is forbidden. It cures forests into kindling on one flank while it aims flash floods at burn scars on another, and along its northern rim, it does something that sounds almost impossible until you watch the reports come in. It converts afternoon heat into hurricane-force wind. Yesterday, on that rim, a town in North Dakota stood under falling ice the size of baseballs for 8 straight minutes, while a weather station down the road clocked a gust at 89 miles per hour. The dome did that too, and understanding how is the key to understanding what this thing does to the country for as long as it refuses to leave. Part 5. The feedback that feeds itself. A dome this strong is not a passive object sitting on the map waiting for something to move it. It is an active machine, and the most unsettling thing about it is what it does to its own life expectancy. Because a mature heat dome, parked over dry ground, manufactures the conditions of its own survival. Understanding that loop is the difference between hoping this ends soon and understanding why the forecasters will not promise you that it does. Start at the ground. When sunlight lands on moist soil, a large share of that energy goes into evaporating water. Evaporation is powerful. It launders incoming solar energy into water vapor instead of temperature, which is why a July afternoon in a wet cornfield, for all its misery, stays cooler than the same afternoon over bare dirt. But when the soil is dry, that laundering service shuts down. Nearly all the incoming energy goes directly into heating the ground and the air above it. the air gets hotter than it otherwise would. And hotter air, as we established when we measured the dome's height, means a taller, stronger ridge overhead. Now close the loop. A stronger ridge suppresses clouds even more effectively, which lets more sunlight through, which dries the soil further, which kills more evaporation, which heats the air more, which builds the ridge higher. Around and around. Drought feeds heat. Heat feeds the ridge feeds drought. Meteorologists call this land-atmosphere coupling, and it is the reason the worst heat waves in history did not simply happen over dry regions. They entrenched over them. So the obvious question is how dry the ground under this dome actually is. The United States Drought Monitor, updated for the week of July 21st, answers it. 65.24% of the country is at least abnormally dry. 45.77% is in formal drought. 29.14% is in severe drought or worse. 10.71% is in extreme drought, and about 1% has reached exceptional drought, the darkest category on the map. Nearly a third of the nation, in other words, is offering this dome the dry ground fuel that the feedback loop runs on, and the driest sectors sit exactly where the ridge is strongest, across the interior west. Those category names are worth translating out of bureaucratic colour coding, because they describe real conditions on real ground. Severe drought, the 29% tier, is the level at which crop and pasture losses become likely, and water restrictions start appearing in local ordinances. Extreme drought, the 10% tier, means major losses and widespread water shortages. Exceptional, the top of the scale, is reserved for the kind of deficit that empties stock ponds and forces ranchers to sell herds. When we say the dome is sitting on a dry ground fuel supply, this is the fuel. Soil that has already surrendered its moisture cannot spend any incoming sunlight on evaporation. So the sun's full paycheck goes to heat, every hour of every cloudless day the dome provides. One number in that report deserves a closer look. The severe drought figure moved by just 0.04 of a percentage point this week. On its face, that sounds like good news, a plateau instead of a climb. But read it in context. The drought is holding at a high level, while the strongest heat of the summer arrives on top of it. The fuel is not building because it is already loaded. The question the next few drought monitor updates will answer, week by week, is whether this dome starts pushing that 29% upward again. If it does, the loop is winning, and the dome's persistence forecast gets uglier with it. Regular viewers have watched this trap assemble itself in slow motion all month. Back on July 10th, we made a video arguing that the last 2 weeks of July would be unlike anything most of the country expected, because the jet stream had locked into a stalled configuration with a ridge fixed over the west. The following day, we covered the first all-time records under that ridge, when Salt Lake City was challenging 107 and Billings was pushing 108, numbers those cities had never officially touched. That forecast has now aged into the event you're watching. The pattern did not break. It ripened. The ridge that was challenging all-time records over the Northern Rockies 2 weeks ago has consolidated, strengthened, and shifted its centre of mass toward the Great Basin, and the atmosphere downstream never managed to dislodge it. What we called a locked pattern 2 weeks ago is today's 431 alerts and a 600 decameter forecast, and the prediction that mattered most, the one about duration, is the one verifying hardest. History says this is exactly how the worst ones behave. The most notorious American heat catastrophes were not fast-moving systems that happened to be intense. They were entrenchments. The 1936 heatwave, which we will meet again later in this video, parked over plains that years of drought and failed farming practice had stripped of moisture, and the bare, dry ground fed the ridge above it for weeks. The same coupling, soil to sky, that forecasters now measure with satellites and model in physics code was operating then, unnamed and unmeasured, doing what it always does. Dry ground and a strong ridge, left alone together long enough, form an alliance. There is one more layer under all of this, and it belongs to the ocean. The Pacific is running an El Niño, with the key monitoring region nearly a full degree Celsius above normal, after one of the fastest cold-to-warm swings on record, and yesterday's video covered what that is doing to the planet's storm basins. For today's story, El Niño matters in a single sentence. This dome is not operating on a neutral planet. It is drawing from an atmosphere already carrying a warmed baseline, which lifts the floor under every record it attacks. Put the whole feedback picture together, and the dome stops resembling weather at all, and starts resembling an organism with a metabolism. It eats sunlight, which the drought lets it digest efficiently. It defends its territory by deflecting storms and starving clouds. It grows taller as it feeds, and its growth improves its feeding. That is anthropomorphism, obviously, and the dome is only physics. But the metaphor earns its keep because it predicts the right behaviour. You do not wait out an organism with a working metabolism. You wait for something to cut off its food, and until something does, it continues. The monsoon completes the machine's defences in a way that feels almost unfair. The seasonal flow of tropical moisture that normally cools the southwest afternoons is being held at arm's length by the dome itself. Sinking air in the dome's core suppresses the monsoon storms directly over the hottest ground, while the moisture gets steered around the perimeter into the Four Corners and the Rockies. The one mechanism the desert southwest relies on every summer to break its own heat is being rerouted by the very structure it would need to break. The rain is real, and we will see shortly where it is going, but the core of the dome sits in a rain shadow of its own making. Add it up, and you can see why breaking a structure like this requires more than patience. It takes either an outside shove, a strong trough of low pressure with enough momentum to physically displace the ridge, or an inside failure, a monsoon surge aggressive enough to wet the ground and cloud the sky until the feedback loop starves. Both of those exits exist. Neither is in the near-term forecast, and that, mechanically, is what the title of this video means. A dome that does not die down soon is a dome whose self-reinforcement is outrunning every process trying to kill it. Every duration disaster we'll meet later in this video, every name on the ledger was a version of this same loop winning for too long in a row. That is worth saying plainly before we go further. The feedback is not a curiosity. It is the mechanism that turns a hot week into a catastrophe, because it is the thing that decides how long the experiment runs. But before we open that ledger, you need to see the dome's other weapon. Because while the interior bakes quietly, the edges of this structure have spent the last 2 days doing something loud. The stored heat does not always stay put. Along the dome's northern rim, it has been converting itself into wind. Not breeze, hurricane force, measured, tree-snapping wind, and ice. Part 6. The Rim, where heat becomes wind. Yesterday evening in the farm town of Forbes, North Dakota, hail 3 inches across fell for approximately 8 minutes straight. Residents reported widespread damage, windows broken across town, and the report that reached the Storm Prediction Center carried a detail that made forecasters look twice. It was not the size of the ice. 3-inch hail, baseball class, is rare but familiar. It was the duration. 8 minutes is a geological age to stand under falling baseballs, and it points at something specific and unsettling about the storms this dome is breeding along its edge. Here is why that number is strange. A typical thunderstorm core, even a severe one, crosses any given point on the map in well under a minute. The storm moves, the hail shaft moves with it, and the barrage passes like a train through a crossing. For giant hail to pound one town for 8 continuous minutes, the storm has to be either nearly stationary or continuously regenerating over the same ground, with an updraft strong enough to keep lofting stones the weight of apples back into the freezing levels again and again. Updraft strength scales with instability, and instability is exactly what a heat dome manufactures in industrial quantities along its rim. The interior heat is the ammunition. The rim is the barrel. Consider what a 3-inch hailstone actually is, physically. It is a layered sphere of ice, built like an onion, each layer recording one trip through the storm. A growing stone rides the updraft into air far below freezing, collects a coat of supercooled water, gets heavy, falls, and if the updraft is strong enough, gets caught and hurled back up for another coat. To keep a stone 3 inches across airborne long enough to build those layers, the rising air beneath it has to be moving upward at highway speeds, on the order of 100 miles per hour inside the storm's core. When a stone that size finally wins its argument with the updraft, it arrives at the ground moving fast enough to crack windshields, strip siding, and put dents in steel. Now imagine that arriving not as a brief volley but as a sustained 8-minute bombardment, thousands upon thousands of stones, over one town. The energy budget for that performance was collected hour by hour from the afternoon heat this dome provided. The reports out of Forbes described exactly the aftermath that arithmetic predicts. Widespread damage, broken windows across town, and spare a thought for what that town's morning looked like, because a hailstorm like that does not just break glass. It shreds gardens and crops to stubble, strips shingles, kills unsheltered animals, and leaves drifts of ice on the ground in 100-degree heat, fog rising off them like the scene of some misplaced winter. Insurance adjusters have a phrase for events like this. They call them total loss hail days. For an agricultural town in late July, with crops standing at full height and weeks from harvest, the timing is close to the worst the calendar offers. Forbes was not an isolated report. Friday, July 24th, produced 51 preliminary severe weather reports across the dome's northern arc, up from 20 the day before, a one-day escalation that mirrors, almost beat for beat, the escalation in the heat alerts we walked earlier. 1 tornado, 36 damaging wind reports, 14 large hail reports, and the wind numbers were not the usual estimated from damage variety, which matters more than casual readers realise. Most severe wind reports in the national database are estimates, inferred after the fact from snapped limbs and downed lines, and estimates carry error bars. These were measurements. South of Wing, North Dakota, a private weather station measured a gust of 89 miles per hour. A mesonet site near Robinson recorded 79 at standard 10-metre height, with 71 even at 3 metres, barely above head height. Another near Mackenzie clocked 75. In Beaverhead County, Montana, a remote automated station measured 75, and far to the south, on the dome's opposite flank, Albuquerque's International Airport recorded a 78-mile-per-hour gust on its official sensors, strong enough to qualify as hurricane force with room to spare. Up in Marshall County, Minnesota, spotters watched a funnel touch down near the town of Middle River, with the report noting possibly 2 rotations on the ground. For scale, hurricane force begins at 74 miles per hour. 4 separate stations across 2 states measured winds at or beyond that threshold on Friday evening. From storms that no hurricane center ever tracked, storms that did not exist at lunchtime and were gone by midnight. That is the RIM's signature. It does not send you a named storm with 5 days of warning graphics. It converts a hot afternoon into hurricane-force wind in the space of a single evening, and the only advance notice is a risk outline on a forecast map that most people never see. Notice the geography of that list. North Dakota, Montana, Minnesota, New Mexico. Those reports trace the rim of the dome like iron filings tracing a magnetic field. The interior, the core over the southwest deserts, stays eerily calm, all subsidence and silence. The violence organizes along the edges, where the dome's heat meets air that still remembers how to move. The mechanism that converts heat into wind deserves a minute, because it is one of the most elegant and dangerous tricks in all of severe weather. Through a long afternoon of extreme surface heating, the lowest 2 or 3 miles of the atmosphere gets stirred into what meteorologists call a deep, well-mixed boundary layer. Hot at the bottom, cooler with height, and critically very dry through most of its depth. On a forecaster's chart, the temperature and moisture traces spread apart into a shape they call an inverted V. That shape is a loaded weapon. When a thunderstorm manages to fire on top of that layer, its rain falls into miles of hot, thirsty air, and it starts to evaporate before reaching the ground. Evaporation absorbs energy, chilling the air inside the rain shaft. Suddenly you have a column of air that is colder, and therefore heavier, than everything around it, suspended miles above the surface. It falls. It accelerates the whole way down like a piston, and when it hits the ground it has nowhere to go but sideways, blasting outward in every direction at highway speeds or worse. That is a downburst, and the hotter the mixed layer and the taller its dry column, the harder the piston drops. An 89-mile-per-hour gust out of a garden-variety cluster of storms is the atmosphere showing you, in one number, how much energy the dome had stored in that boundary layer by evening. The heat you measured at 5 in the afternoon and the wind that snapped power poles at 10:15 were the same energy in 2 different costumes. Downbursts also reproduce. When that piston of cold air hits the ground and spreads, its leading edge becomes an outflow boundary, a miniature cold front racing away from the parent storm. Where that boundary ploughs into hot, unstable rim air, it shovels it upward, and the lifted air can ignite a brand new storm, which produces its own downburst, which launches its own boundary. On evenings like Friday, The northern plains become a billiard table of colliding outflows, each collision a candidate for the next tower, and the whole system can leapfrog eastward for 6 or 8 hours on heat the dome bank that afternoon. Even the Middle River tornado fits the family portrait. Along sharpening boundaries like these, colliding outflows can spin up brief tornadoes with little of the usual supercell warning, which is consistent with spotters describing a funnel with possibly 2 circulations on the ground rather than one classic cone. And this is where the rim connects back to everything else in this video. The severe weather along the dome's edge is not a separate news story that happens to share a week with the heat. It is a direct physical readout of the interior: hotter core, deeper mixing, harder downbursts, stronger dome, sharper rim. Every day the dome refuses to die down, the gun reloads, and the towns living along the northern arc from Montana to Minnesota get another evening of finding out whether their particular stretch of the rim goes off. Yesterday, the answer for Forbes and Wing and Middle River was yes, which brings us to the uncomfortable part. Yesterday's arsenal has already been rebuilt. As of this morning, the Storm Prediction Center has drawn its risk areas for today, and the bullseye sits over central Montana and western South Dakota, where the forecast calls for something that reads like a physics problem, designed to produce exactly what we just described. First, heat the plains of South Dakota to 105 degrees, then wait for sunset. Part 7, today's loaded gun, 105 degrees, then the wind. The Storm Prediction Center's morning outlook for today, July 25th, carries a slight risk of severe thunderstorms across central Montana and a broad stretch of South Dakota, and the forecast discussion behind it explains the setup with unusual directness. Very strong heating is expected across western and central South Dakota, with temperatures in some areas rising to near or above 105 degrees. That heat builds the same deep, dry, well-mixed layer we just anatomized. And into that environment, storms are expected to develop off the Black Hills and the Montana high terrain by mid to late afternoon, then spread east into the evening. The center's own words for the outcome: localized gusts of 75 miles per hour or higher cannot be ruled out. The Montana side of the risk has its own machinery. Convection firing near the mountains in the early afternoon is forecast to be nudged eastward by a subtle disturbance riding the rim of the ridge, what forecasters call a low-amplitude mid-level vorticity maximum, essentially a small wrinkle of spin surfing the dome's northern edge. As those storms move off the terrain into the superheated air of the eastern Montana plains, the outlook expects them to organize into one or more outflow-driven clusters, storm complexes that propagate on their own cold exhaust, each downburst seeding the next storm's inflow, a chain reaction that can march for hundreds of miles into the night. South Dakota's version is the one the forecasters flagged with the most interest. Moisture out there is sparse, dew points only in the 50s, which would normally starve thunderstorms, but the sheer depth of heating changes the math. The outlook notes that with the air mass mixing to extreme depths under 105-degree surface temperatures, storms can tap instability of around 1,000 joules per kilogram, modest on paper, while the real weapon remains that towering dry layer underneath. This is the paradox of dry heat severe weather. The drier the boundary layer, the weaker the rain, and the stronger the wind, because every drop that evaporates on the way down is another increment of cold, heavy air added to the piston. Some of the model guidance, the discussion adds, develops a persistent cluster or loosely organized mesoscale convective system tracking eastward across South Dakota along a weak surface boundary. If that scenario verifies, the center warns of a corridor of more organized severe wind threat, with gusts potentially near or above 75 miles per hour. Translate the jargon. A mesoscale convective system, an MCS, is a thunderstorm complex that has graduated from being a collection of storms into a single self-sustaining machine, often 100 miles or more across, capable of producing a continuous swathe of damaging wind rather than isolated pockets. The machine runs on its own exhaust. Rain-cooled air pools beneath the complex into a dome of cold, dense air called a cold pool, and the leading edge of that pool ploughs forward like a snow shovel, forcing hot rim air upward into new storms, which produce new rain, which feeds the cold pool, which ploughs further. Once that engine engages, the system no longer needs the sun. It can run all night, straight through the hours when ordinary storms starve, and the longest-lived versions cross multiple states before dawn. The strongest earn the name derecho, Spanish for straight ahead, reserved for wind-damaged swathes at least 400 miles long. Nobody is forecasting a derecho today. What the forecast is saying is that the ingredients on the table, extreme heat, a towering dry layer, a boundary to focus the storms, and a wrinkle of upper-level energy are the ingredient list from which such machines are assembled, and at least some of the models keep assembling one. If you live anywhere along that rim, from central Montana across South Dakota into Minnesota, the practical version of all this physics is short. These storms arrive fast. Their first act is often the wind itself, and the gap between hearing distant thunder and losing shingles can be minutes. The Storm Prediction Center's morning outlines are public, free and updated through the day, and on rim days like this one they are worth 30 seconds of your attention around lunchtime, because the difference between a downburst finding you in a field and finding you indoors is most of the difference that matters. There is a second, quieter risk area today that deserves attention, because it shows how far the rim's reach extends. Across northern and eastern Minnesota into Wisconsin and upper Michigan, a front will be draped along the dome's edge by late afternoon, with moderate to strong destabilization forecast south of it, and effective shear exceeding 50 knots above it. Shear is the change of the wind speed and direction with height, and it is the ingredient that organizes storms, tilting them so their updrafts and downdrafts stop interfering with each other and letting them persist and rotate. 50 knots is supercell-grade organization, sitting on the shelf, waiting. The forecaster's confidence that storms actually fire in that environment today is genuinely low, and they said so, holding the risk at a marginal level. But their own discussion concedes that if storms do develop during the afternoon or evening, a threat for hail, damaging wind, and possibly a tornado could evolve, and that even if the daytime stays quiet, vigorous elevated storms may develop over the same area late tonight. A loaded environment with an uncertain trigger is still a loaded environment. It sits exactly where the rim's geometry says it should. Then comes Sunday, and the whole apparatus slides east. The Storm Prediction Center's Day 2 outlook places a slight risk over the upper Mississippi Valley into the upper Midwest, from Minnesota across Wisconsin toward the Great Lakes. The morning may open with elevated storms riding warm, moist air flowing up and over the dome's shoulder, carrying a hail and wind threat of their own. By evening, a stronger disturbance cresting the ridge out of the Canadian prairies is forecast to focus new development over Minnesota, and the discussion raises the possibility of upscale growth into a forward-propagating MCS, which would, in the center's words, increase the potential for a swath of severe wind gusts. Chicago's forecast office, watching the same models, sketched a scenario in which a complex of storms drops south down the length of Lake Michigan Sunday night, while candidly admitting the predictability of such features is limited to about a day. Their phrasing deserves quotation, because it is the truest sentence in any of today's forecasts. That scenario is certainly plausible, they wrote, but so are about 1,000 other scenarios. Sunday's setup carries one more mechanism worth naming, because it explains why the Midwest's dangerous storms so often arrive in the dark. The dome's shoulder acts as a ramp. Warm, humid air streaming north along the ridge's edge glides up and over the cooler air near the surface, a process called warm advection, and storms ignited that way float above the ground on a cushion feeding from an elevated reservoir of unstable air. They do not need afternoon sunshine, so they fire at 2 in the morning, and they specialize in hail and wind delivered to people who went to bed under clear skies. The Storm Prediction Center's Sunday discussion anticipates exactly this flavor for the morning round, before the stronger evening threat organizers, on the rim of a dome the danger clock does not keep business hours, step back from the daily mechanics and watch the pattern instead, because the pattern is the story. Friday, the rim went off across North Dakota and Minnesota. Today the loaded segment is Montana and South Dakota. Sunday, it is Minnesota, Wisconsin and the lakes. Day by day, the discharge zone slides along the dome's northern boundary, like a flame following the edge of a piece of paper. The interior heat never moves. The violence orbits it, and that is the deal the northern plains have been handed for as long as this dome persists. Every afternoon the interior spends at 105 or better is an afternoon the rim spends charging. The persistence question in this video's title is not just about how many days Phoenix spends above 115. It is about how many more evenings some town on the rim, in Montana or the Dakotas or Minnesota, gets to find out what 8 minutes of falling ice or an 89-mile-per-hour piston of cold air does to a place with a grain elevator and 400 people. The dome's duration is their exposure too. 2 flanks of this machine remain, and they are the 2 that decide whether a long dome merely exhausts the country or actively starts taking pieces of it. One flank is on fire, the other one floods. Part 8. The Fire Flank and the Monsoon's Bargain. At this moment, on the dome's northwestern flank, 3 major wildfires are burning with containment numbers that should worry anyone who reads them next to the heat forecast. The Crosswhite Fire in Oregon has consumed 143,341 acres and stands at 19% contained. The Kaiser Canyon Fire in Washington has burned 106,935 acres at just 13% containment. And the Big Grass Fire in Oregon, which did not exist until July 23rd, has already run to 65,000 acres and is 5% contained. 5% on a fire that grew to the size of a small county in under 48 hours. Pause on those containment numbers because they are widely misread. Containment does not measure how much of a fire is out. It measures what fraction of the fire's perimeter has a control line around it that crews believe will hold. 5% contained means that along 95% of the Big Grass Fire's edge, there is nothing between the flames and the next 65,000 acres except terrain, weather, and luck. And the weather variable in that sentence is the one this dome controls. Wind, humidity, and fuel dryness set how fast a fire's open edges run, and the dome is currently setting all 3 against the crews. The wider board is worse. Satellite sensors logged 3,561 active fire hotspots across the country in the last 24 hours. Red flag warnings are posted across Idaho, Montana, and Oregon, with afternoon relative humidity forecast as low as 13%. To calibrate that number, the humidity inside the Sahara on a summer afternoon commonly runs around 25%. Whole stretches of the interior Northwest will spend today drier than the world's benchmark desert. And the Storm Prediction Center's fire weather outlook includes a critical risk area alongside something called an isolated dry thunderstorm zone, which is the fire community's least favourite phrase in the language. Dry thunderstorms are storms whose rain evaporates before reaching the ground in exactly the kind of parched dry layer we have been describing all video, which means they deliver lightning to cured fuels with no water attached. Every strike is a potential ignition with nothing falling behind it to slow the spread. Some of the most destructive fire sieges in Western history began as a single night of dry lightning walking across cured range, and the ingredients for that kind of night are now on the same forecast maps as the record heat. Connect this flank to the machine. Each day the dome persists, it runs a drying oven over millions of acres of grass, brush and timber, pulling moisture out of living and dead vegetation alike, and pushing fuel conditions further past the thresholds fire behavior models use to flag extreme spread potential. The dome does not light the fires. It manufactures the conditions under which any ignition, a lightning strike, a dragging chain, a hot exhaust pipe, becomes a run instead of a smoulder. Firefighters then have to work those runs in 100+ degree heat, in the same conditions that make heat stroke a hazard for someone standing still. Think about what a fire line actually demands. Miles of hiking under load, hand tools swung for hours, protective clothing designed to stop embers and therefore, by its nature, to trap body heat, all performed next to an active combustion source in air the dome has already heated past the body's operating margin. Crews on the big western fires are already rotating through shortened shifts and mandatory cooling breaks, which is the correct medicine, and also means fewer hands on the line per hour, on fires whose open perimeters are growing. A long dome does not just raise the odds of a fire siege, it degrades the capacity of the people who would fight it, hour by hour in the same motion. Meanwhile, on the dome's southern and eastern flanks, the opposite element is staging. The monsoon moisture the dome exiled from its core is wrapped around its perimeter, and the forecast keeps it firing. The Weather Prediction Center expects daily rounds of thunderstorms from the Four Corners across the central and southern Rockies, with locally heavy rainfall, and it names the specific vulnerability in its discussion. The heaviest cells will threaten burn scars and slot canyons, where rapid runoff and flash flooding may occur. Denver's forecast office measures the incoming moisture at 150 to 175% of normal for early next week and expects storms with locally heavy rain each afternoon, even as the same office forecasts record-challenging heat, record heat and flash flood risk in the same city in the same 5-day forecast. The dome's perimeter is where the atmosphere runs both extremes at once, and here is the bargain, the double bind that closes this act. The monsoon is the one natural mechanism on the map that could genuinely undercut this dome from the inside, by soaking the soil and shading the sky until the feedback loop starves. But a monsoon surge strong enough to do that would arrive over a west that this same dome has spent weeks preparing to shed water instead of absorb it. Burned slopes develop a water-repellent crust, hydrophobic soil, created when a fire's heat vaporizes waxy compounds in vegetation and drives them down into the ground, where they condense into a layer that repels water like a freshly sealed driveway. Rain that lands on that crust does not soak. It sheets, gathering ash, soil and rock as it accelerates downhill, and within minutes a burn scar can convert an ordinary thunderstorm into a debris flow, a moving slurry with the consistency of wet concrete and the stopping power of neither. Slot canyons do the same conversion by geometry instead of chemistry, concentrating a storm that fell across miles of desert into a channel a few feet wide, so that a wall of water arrives under blue sky, fed by rain nobody in the canyon ever saw. The exits from a long heat dome are not clean. Option 1, the monsoon stays suppressed, and the heat and the fires continue uninterrupted. Option 2, the monsoon surges, the heat breaks, and the burn scars flood. The dome has arranged the board so that even its own death carries a cost. So that is the machine in full, a self-feeding core running record days and record nights, a rim converting stored heat into wind and ice on a daily cycle, a fire flank curing toward ignition, a moisture ring aimed at burned ground. Everything you've seen so far is the dome operating normally, day by day, exactly as the physics says it should. Which is what makes the next question the real one. What happens when normal operation simply continues? Not a bigger dome, not a hotter afternoon, just this, held in place week after week. The honest answer is that we do not have to speculate, because the atmosphere has already run that experiment on American cities 3 times in the modern era, and it kept meticulous records each time. The most recent trial ran 3 summers ago, in the same city that just tied its warmest night in history. The results were published. 645 people did not survive the study. Part 9, Phoenix, 2023. The template. 3 summers ago, in this exact city, the atmosphere ran the full version of the experiment this dome is now proposing, and it is worth walking through what happened day by day, because it is the closest thing we have to a completed answer sheet for the question in this video's title. On the last day of June 2023, Phoenix hit 110 degrees. It did it again on July 1st and July 2nd, and then it simply never stopped. Every single day of July, all 31 of them, reached 110 degrees or hotter. The previous record for consecutive days at that threshold was 18, set back in 1974, and it had stood untouched for half a century. 2023 did not edge past it. It nearly doubled it. Somewhere in the middle of that stretch, on July 19th, came the night we have already met, the low of 97 degrees, the warmest night in the city's history, the exact mark this current dome just tied on its opening weekend. When the month was over, the accountants of climate did their arithmetic and found something that had never appeared in an American ledger before. Phoenix's average temperature for July 2023, counting every daytime high and every overnight low across the full month, was 102.7 degrees. Not the average high, the average of everything. It remains the hottest month ever recorded in any city in the United States, and it was not achieved with one freakish week. It was achieved with relentless, unbroken day-after-day persistence, duration, given a diploma. Then came the other ledger, the one that takes months to close because its entries have to be certified one at a time by medical examiners. When Maricopa County's Public Health Office finished its review of the summer, the count of heat-associated deaths for 2023 stood at 645 people, in one county, in one summer. To put that number in national context, those 645 deaths amounted to more than half of all heat deaths reported to the Centers for Disease Control from the entire United States that year. One metropolitan area, running one long experiment in duration, generated the majority of the country's certified heat mortality. The shape of those deaths matters as much as the count, because the shape is what a persistence event looks like in human terms. The deaths did not spike on the hottest afternoon and subside. They accumulated, building through the streak and peaking weeks into it, because heat mortality is a lagging cumulative process. Each unrecovered night left hundreds of thousands of bodies slightly more depleted than the morning before. Dehydration compounds, cardiovascular strain compounds, medications that impair heat regulation, and there are many, from diuretics to antipsychotics to common blood pressure drugs, keep doing their quiet work. People who survived the first week of the streak comfortably were, by week 3, in physiological territory they had never visited, and some of them were people with no idea they were vulnerable at all. The city around them was accumulating damage on the same curve. Emergency departments spent the streak treating a category of injury most of the country never thinks about. Contact burns from the ground itself because pavement under a 115-degree sun can reach surface temperatures around 180 degrees, hot enough to inflict serious burns in seconds on anyone who falls and cannot immediately get up. For the elderly living alone, a stumble on a sidewalk became a burn emergency. For the unhoused, every hour of shade lost was an exposure event. Cooling centres extended their hours and still could not reach the people who did not know they qualified as vulnerable, because the cruelest feature of heat illness is that impaired judgment is one of its symptoms. The overheating brain is a bad judge of its own overheating. By the time a person feels confused about whether they need help, they're usually well past needing it. There is also a bureaucratic texture to a duration event that the temperature graphs never show. Maricopa County certifies its heat deaths through a deliberate medical review case by case, which means the true shape of a summer only emerges months later, in reports issued long after the weather has moved on. Through the streak itself, the public running count showed only a fraction of what the final audit would confirm. That lag is worth remembering in real time this summer, right now. Whatever numbers appear in headlines during the current dome will be provisional, and if the template holds, they will be revised in one direction only. And the roll call of who died follows the same pattern in every American heat disaster, which is why it bears stating plainly. The elderly, especially those living alone, whose bodies regulate heat poorly and whose isolation means nobody notices the fan is broken. Outdoor workers, for whom the heat is not an ambient condition, but an occupational exposure measured in hours. People with chronic illness, and in Phoenix specifically the unhoused, for whom the pavement itself becomes a burn hazard at these temperatures and shade is a resource to be competed for. A county the size of Maricopa contains hundreds of thousands of people in those categories, and a duration event holds all of them underwater at once for weeks and counts on nobody's grip slipping. Understand also what the streak does to the physical city as it lengthens, because the ratchet mechanism works on infrastructure exactly the way it works on bodies. Each 110-degree day launches from the floor the previous night set. The pavement starts the morning warmer. The buildings start warmer. The water in exposed pipes runs hot from the cold tap by afternoon. A detail Phoenix residents know and the rest of the country finds surreal. Air conditioners that cycled off for a few overnight hours in week 1 are running continuously by week 2, and machinery that never rests fails at higher rates, which means the repair backlog grows exactly as fast as the need for repairs becomes life-critical. A city 3 weeks into a streak is not the same city that entered it, even if the thermometer reads the same number on both days. That is what duration means physically. The number stays constant while everything beneath it degrades. One more feature of that accounting deserves respect. Heat death counts are floors, not ceilings. A death is certified as heat-associated when the evidence is explicit, a core temperature, a scene, a circumstance. But heat also kills by proxy, tipping heart attacks, strokes and kidney failures that get certified under those causes instead. Epidemiologists who study excess mortality, the statistical difference between how many people died and how many normally would have, consistently find that the true toll of major heat events runs well above the certified count. Whatever number you hear in a heat disaster, the honest assumption is that reality was worse. So that is the template. A streak of 110-degree days that would not break, nights that never released, a mortality curve that lagged the temperature curve by weeks and then kept climbing after the cameras left. Now lay 2026's opening position over that template point by point, because the comparison is the most important exercise in this video. A record daily high, 1 degree hotter than the same date in the template year. Check. The template's single worst night, the 97-degree low that stood alone in the record books for 3 years, already tied in July's 4th week with the dome still strengthening toward its 600 decameter ceiling. Check. Extreme heat warnings posted with no relief behind them and the possibility of 120 at the peak, a number the template summer itself never reached, and a federal forecast that extends the heat into August, which is precisely the calendar window where the template did its killing, the weeks when the accumulated physiological debt across a metro area of 5 million people came due. The current dome has not yet run long enough to match the template's streak, and it may never. That is the honest caveat. But what it has already done is match the template's signature marks earlier in its own life, from a higher starting floor, with its peak strength still ahead of it, and with the exact same city as its test population. If you wanted to rerun the 2023 experiment under slightly harsher initial conditions, the setup on the board right now is approximately what you would build. That is what doesn't die down soon means in this city's own recent memory, not an abstraction. A ledger with 645 names, closed 3 years ago, sitting in a filing cabinet 12 miles from the airport thermometer that just tied the warmest night in its history. And Phoenix is only the most recent volume. The duration rule has been written twice more in living memory, in 2 cities that could not be more different from the desert or from each other, and the mechanism was the same both times. The nights, always the nights. Part 10, Chicago, Lytton, and the Duration Rule. In the middle of July 1995, a heat dome settled over the upper Midwest, and in the space of roughly 1 week, 739 more people died in Chicago than the actuarial table said should have. We have told pieces of this story on the channel before, in our June coverage of Why Warm Nights Kill, so we will not rebuild the full case file. But this video's question, the duration question, is the lens that makes Chicago legible, so the essentials belong here. The headline temperatures were serious but not planetary. Chicago touched 106 at its peak, a number that Phoenix would file under Tuesday. What made the event lethal was everything underneath the headline. Humidity off the saturated cornfields kept the heat index near 120 and, critically, kept the nights in the low 80s, which for Chicago's building stock was catastrophic. Brick tenements and public housing towers, built to hold warmth against Midwestern winters, absorbed the heat and would not release it. Indoor temperatures in the worst apartments stayed above 90 around the clock. Air conditioning was scarce in exactly the neighborhoods where the vulnerability was concentrated, and fear kept windows shut in buildings where an open window at night felt more dangerous than the heat. For 3 consecutive nights, the city's most vulnerable residents got no recovery window at all. By the time the pattern broke, the medical examiner's office had run out of space, and refrigerated trucks idled in the parking lot, an image American cities had never associated with weather. The most enduring lesson of Chicago came later, from the sociologists who performed what one landmark study called a social autopsy of the disaster. When researchers mapped where the deaths clustered, the pattern did not simply track the temperature, which was roughly uniform across the city. It tracked isolation. Neighborhoods with active street life, busy shops, and dense social ties lost far fewer people than demographically similar neighborhoods where residents lived alone behind locked doors, even when the two sat side by side under the same sky. The heat was the weapon, but the exposure was social. A duration event does not just test bodies, it tests whether anyone knocks on the door by day 9, and that finding is the entire scientific basis for the advice that sounds like a greeting card. Check on your neighbors. In the one American heat disaster studied more closely than any other, being checked on was statistically the difference between living and dying. 26 years later, the same rule executed in the opposite climate. In late June 2021, a heat dome of almost absurd intensity parked over the Pacific Northwest, a region whose entire relationship with summer assumed such a thing was impossible. Portland reached 116, Seattle 108, and in the interior of British Columbia, a village called Lytton recorded 49.6 degrees Celsius, 121.3 Fahrenheit, the highest temperature ever measured in Canada, hotter than anything in the recorded history of Europe or South America. The following day, a wildfire ignited near the village, ran through the tinder the dome had spent a week curing, and burned most of Lytton to the ground. The town that set a national heat record and the town destroyed by fire were the same town, 24 hours apart. Across Oregon, Washington, and British Columbia, the excess mortality accounting attributed hundreds of deaths to that single week, and the underlying vulnerability was the mirror image of Chicago's. It was not old brick holding heat. It was a population and a housing stock with functionally no air conditioning, because until that week the climate had never demanded it. The Northwest's homes were built to hold warmth, its people had no heat experience, and its nights, the famous cool Pacific nights that were supposed to be the region's insurance policy, stayed in the 70s and 80s while the dome held. The 2021 Northwest Dome also carries a scientific distinction that belongs in this story. When attribution researchers analysed it, an event that shattered Canada's national record by nearly 5 degrees Celsius, their finding, which we covered at length in our June video on the 2021 disaster, was that heat of that magnitude in that place was virtually impossible without the warmed baseline the climate now runs on. Not unlikely, virtually impossible. That is the quiet fact under this entire genre of event. The atmosphere is not inventing new machinery. Ridges, domes, and blocked patterns are as old as weather. What has changed is the floor they launch from, which converts what used to be a bad week into record-annihilating territory. Go back one more generation for the oldest volume on the shelf. In July 1936, at the bottom of the Dust Bowl years, a heat wave settled onto the plains in the Midwest that still holds a startling share of America's all-time state temperature records. North Dakota reached 121 degrees that month, a state record that stands to this day, set in the same general plains that this weekend's forecast is pushing back through 105. The 1936 event ran for weeks over ground. The drought years had stripped bare. The feedback loop we described earlier operating at full power decades before anyone had named it. Families slept in parks and on fire escapes because the indoors was unbearable, an era's version of the recovery problem, and the national death toll ran into the thousands in a country with no air conditioning to lose and no grid to strain. 90 years later, the same plains sit under a version of the same ridge, except now there is a grid and everything depends on it. Line the three up and the rule writes itself. Chicago was 3 nights. The Northwest was about a week. Phoenix was a month. Different climates, different decades, different victims, one constant. In every case, the atmosphere's peak reading made the news, and the atmosphere's refusal to reset at night did the killing. The National Weather Service's own 30-year averages make the point at national scale. Heat is the leading weather killer in the United States, ahead of hurricanes, floods, and tornadoes, ahead of lightning and cold combined, and it earns that ranking almost entirely through events like these, the long ones, the ones that stopped moving. Each disaster also shared one more ingredient, and it is the quiet variable in this whole subject, a mismatch between the event and the place it landed. Chicago's mismatch was housing built for winter plus social isolation. The Northwest's was a total absence of cooling infrastructure. The Dust Bowls was an agricultural civilization living directly exposed on the land. The heat found, in each case, the specific thing a region could not do, and pressed on exactly that. So apply the audit to 2026's board. The Southwest's mismatch is dependence, a civilization of millions that is fully, structurally committed to air conditioning, stacked on a grid running at record load in one of the fastest warming large cities in the country. The Northern Plains mismatch is inexperience, and it deserves a beat of respect, because it is the 2021 lesson wearing new geography. Montana and the Dakotas are cool climate country. Homes there are built like the Northwest's were to hold heat in, not shed it. Air conditioning is far from universal. Heat literacy is low for the same reason hurricane literacy is low in Ohio, and the population skews rural and older, with long distances between a farmhouse and help. When the forecast hands that region multiple days above 100 with warm nights behind them, it is handing a Northwest-style test to a population that watched the 2021 disaster on the news and reasonably concluded it was about somewhere else. And the Midwest mismatch is the oldest one. Humidity and warm nights over aging housing stock in dense cities, the Chicago formula, unretired, with the corn-fed dew points we met earlier supplying the humidity half on schedule. This dome is currently pressing on all three at once, and the forecast gives it into August to choose, which is the correct moment to tell you about the study, because in 2023 a team of researchers asked the precise question this ledger has been circling. They took the Phoenix mismatch, dependence, and asked what happens if the thing being depended on fails during a heat wave. Then they published the number. It is the worst number in this entire video. Part 11. The number nobody wants. Blackout plus. Heat. Brian Stone Jr. is a professor at Georgia Tech who has spent his career studying how cities amplify and mismanage heat, and he has a sentence that should be printed at the top of every emergency management plan in the Southwest. A blackout during a heat wave, he has said, is, quote, probably the greatest climate-related hazard we can imagine. In 2023, Stone and his colleagues published a study in the journal Environmental Science and Technology that put hard numbers on that sentence for the first time. The team modelled a specific compound scenario, Phoenix, a multi-day heat wave, the kind the city experiences routinely, and a citywide, multi-day electrical blackout, the kind that a cascading grid failure, a cyber attack, or a critical equipment loss could plausibly produce. They built the city in silicon, simulated the indoor temperatures of its housing stock hour by hour with the air conditioning dead, and applied the medical literature on what those exposures do to human bodies across the city's actual demographics. The results were on the order of 13,000 deaths, and roughly 800,000 people, about half the population of the city needing emergency medical care. Read those numbers again. Not 1,300. 13,000 in one city in a matter of days, with the emergency system that is supposed to respond simultaneously flooded by a caseload 50 times beyond any surge it has ever planned for. Picture the practical version. Every hospital bed in the metro filled within the first day. Ambulance response times collapsing not because crews fail, but because arithmetic does. Triage in parking garages, because garages are shade. And all of it unfolding in a city where the working assumption, reasonable on any normal day, is that help arrives when called. For comparison, the deadliest natural disaster in modern American history, the Galveston hurricane of 1900, killed an estimated 6,000 to 12,000 people. The Stone scenario sits in that band, and it requires no hurricane, no earthquake, no explosion. It requires only two ordinary failures, heat and outage, arriving on the same days. One of the study's co-authors is worth naming because his job title is the whole story in miniature. David Hondula is a heat researcher who became the first director of Phoenix's Office of Heat Response and Mitigation, the first municipal office of its kind in the country. When the study's numbers came out, Hondula said, quote, "This is the first time we have seen a number, and it's obviously quite an alarming number. Sit with the institutional picture there. The city knows." The man the city hired to manage heat co-authored the paper, quantifying the city's worst case. This is not a fringe scenario being shouted from outside the walls. It is the official nightmare, published, peer-reviewed, and sitting on the desk of the person responsible for it. Why is Phoenix's number so catastrophic? Because the city is a marvel of conditional habitability. In the pre-air conditioning era, Phoenix held about 100,000 people who built with thick adobe, slept on porches and rooftops, and organized life around the heat. The metropolis of today, approaching 5 million across the county, exists on entirely different terms. Its housing stock, lightweight, sealed, sun-facing, is designed on the assumption of continuous mechanical cooling. Kill the power, and the study found indoor temperatures in much of that stock climb past survivable thresholds within hours, not days. There is no architectural fallback, no porch sleeping tradition, no thermal refuge built into the buildings themselves. The margin between a functioning Phoenix and an unsurvivable one is, almost exactly, the width of the electrical grid. Which returns us, one more time, to the detail from this week's local reporting. Homes holding in the high 80s, with the air conditioning running. That is what the leading edge of the Stone scenario looks like from inside a living room. The machines are not failing. They are maxed. Every degree the dome adds outside subtracts margin inside, and the same heat that eats the cooling margin simultaneously fattens the electrical load, as several million compressors run flat out through the very hours the grid's own equipment is heat-stressed. Transformers shed load capacity as they get hotter. Transmission lines sag and lose efficiency. Power plants, including the ones that boil water for steam, run less efficiently in extreme heat. Demand rises as capacity strains, on both sides of the same meter, and every additional day of the dome ratchets both curves in the wrong direction. and notice who else needs the nights. The grid's equipment recovers on the same schedule as the human body. Overnight is when transformers shed their accumulated heat into cooler air, when demand normally sags enough for stressed components to rest, when maintenance crews can work de-energized lines without the afternoon load. A 97-degree night takes that recovery window away from the hardware, just as surely as it takes it from the people. The body, the air conditioner, and the transformer are all night shift healers, and this dome has put all three on 24-hour days simultaneously. When utilities set their all-time demand records, and the Southwest utilities have been resetting theirs repeatedly in recent record summers, those records are set in exactly these conditions, at the intersection of a hot afternoon, and a fleet of equipment that never got its night off. The grid operators planned for this, and to their enormous credit, the Southwest grid has so far carried every record summer thrown at it. But the Stone Study's premise does not require the grid to be badly run. It requires one wrong afternoon, one cascading fault, one fire taking the wrong transmission corridor inside a long enough dome. Duration is the multiplier on the dice. The study did not stop at the catastrophe, and neither should we, because its most underreported findings are the hopeful ones. The same model that projected 13,000 deaths tested the city's available defences. Street trees shading half of Phoenix's street segments cut projected deaths by 27%. Highly reflective cool roofs deployed across the building stock cut them by 66%. 2/3 of the worst case, erased by paint and shade by decisions a city can simply make. The physics is almost embarrassingly simple. A white roof reflects the sun's energy back through the atmosphere instead of banking it in the building. A shaded street never receives the energy in the first place. Neither defense draws a single watt from the grid, which is exactly the point, because they keep working on the day the grid does not. The gap between the nightmare number and the achievable number is not technology. It is implementation speed, and implementation is measured in years while domes are measured in days. At the household scale, the same logic applies, and it is worth 30 seconds of plain talk for anyone watching from inside this dome. The Stone scenario's lesson for an individual is that your cooling plan should not have a single point of failure. Know where your nearest public cooling centre is before you need it, because searching for one during an outage, in the heat, on a dying phone, is the failure mode. Keep water stored more than feels reasonable. If someone in your home is elderly, chronically ill, or on heat-sensitizing medications, treat any outage lasting past an hour as the moment to relocate, not to wait. None of that stops a blackout. All of it moves individual people off the steepest part of the study's mortality curve, which was built from the homes where nobody left in time. So place this piece properly in the answer to our title. If the dome does not die down soon, the odds of the blackout coincidence do not stay constant, they compound. A 3-day dome and a 30-day dome are different lotteries played with the same numbers, and the 30-day version buys 10 times the tickets. Nothing about the scenario requires anything unprecedented to happen. Everything it requires is already on the board, and the dome's duration is the hand turning the crank. The ledger is now open on the table. Phoenix 2023, the duration template. Chicago and the Northwest and 1936, the rule in 3 climates. And the Stone number, the quantified worst case waiting at the intersection of persistence and bad luck. What remains is to assemble all of it into the direct ranked answer to the question we started with, and then, because this channel deals honestly or not at all, to test the theories flying around this event and lay out exactly what to watch in the days ahead, checkpoint by checkpoint, as the atmosphere decides which version of this story we get. Part 12. The Worst Case Ladder. So let us finally answer the question directly. What happens if the heat dome over Southwest America does not die down soon? The honest answer is not a single scenario. It is a ladder. 5 rungs, each one reached by nothing more exotic than the previous rung continuing. Climb it with me, and notice as we go how far up we already are. Rung 1 is the records cascade, and it is not a prediction, because it is already underway. Daily records fall first, the way 117 fell in Phoenix on July 24th, because daily records are the shallowest water. There are 365 of them per station per year, and a strong dome parked over a station will collect them the way a broom collects dust. Hold the dome a week, and the monthly records come into range, the way July 2023's 102.7 degree month arrived only after weeks of accumulation. because a monthly record cannot be sniped by one hot afternoon. It has to be earned by persistence, which is exactly what this scenario supplies. Hold it longer at full strength, and the all-time marks step onto the board: Phoenix's 122, Denver's 100-degree mark from 1910 that this very weekend has in play, the state records that have stood since the 1930s. Every day of persistence raises the launching floor. A city that starts its afternoon from a 97-degree dawn needs less help to reach historic territory than one starting from 84. And records are not merely trophies. Each one becomes the new floor for the next event, the recalibrated baseline that next summer's dome launches from, which is how a climate ratchets upward in practice, one broken book at a time. The scoreboard has already started turning over, and the scoreboard is also the foundation. Rung 2 is the duration ledger, the Phoenix 2023 template replayed. This is the rung where nothing dramatic appears on television, and that is precisely its danger. No single day makes history. The streak simply refuses to end. The nights hold in the 90s, and the slow arithmetic we walked in the last act begins, the compounding dehydration, the medication interactions, the isolated elderly, the outdoor workforce, the accumulating debt that gets certified months later in a public health report. The entry requirements for this rung are humiliatingly low. It needs no new records at all. It needs 3 or 4 weeks of what the Southwest is already experiencing this weekend, and the forecast extension into August is, functionally, a forecast of this rung's entry conditions. And rung 2 is wider than Arizona this time, which is the underappreciated part. The same duration mechanics apply, scaled by local vulnerability, to every region inside the 431 alerts. The Midwest version runs on humidity and aging housing, the Chicago formula. The Northern Plains version runs on inexperience and thin cooling infrastructure. Texas and the Gulf Coast's version runs on sheer calendar length, because their forecast holds triple-digit indices on most days, with August, the climatological peak, still entirely ahead. A national duration event is not one ledger. It is half a dozen regional ledgers accumulating in parallel, each with its own lag, and the national accounting at summer's end simply adds them up. Rung 3 is the grid coincidence, the stone scenario, and we will not rebuild it here beyond its one-sentence shape. A routine regional blackout, landing inside a mature dome, converts a heat emergency into the deadliest natural disaster in modern American history within about 72 hours. What moves this rung is not the dome getting worse. It is the dice getting rolled more times. Duration multiplies exposure to ordinary bad luck, and ordinary bad luck is the only additional ingredient this rung requires. Rung 4 is the fire blow-up. The flank we toured in Act 2, 3 megafires under 20% containment, thousands of hotspots, humidity below the Saharas, and a dry lightning risk drawn on the same maps as the record heat. The rung engages when ignition meets cured fuel at scale, a single outbreak night of dry storms walking across Oregon or the northern Rockies, converting the dome's weeks of drying into simultaneous fire starts faster than crews can triage them. And fire on this rung does not stay a land management story. Smoke rides the dome's circulation for hundreds of miles, and the 16 air quality alerts already active nationally are the current modest version of what a truly bad ignition week would multiply. Sealed windows and filtered air ordered for millions of people in the middle of a heat emergency, when sealed windows are themselves a heat hazard for anyone without working cooling. Fire takes transmission corridors, which reaches straight back up to rung 3, because some of the highest consequence blackouts in Western history have been fires and power lines finding each other in bad weather. And suppression resources drawn west leave the next ignition less answered. A national queue with more fires than crews. The dome has been charging this rung daily, and unlike the others, it only has to fire once. Rung 5 is the monsoon double bind, the exit that costs. If the moisture ring surges inward hard enough to break the heat, it arrives over burn scars and slot canyons as flash flooding and debris flows, trading the slow emergency for a fast one. The preview is already running. Denver's forecast holds record-challenging heat and locally heavy monsoon rain in the same 5-day window, and the Four Corners daily storm chances sit directly atop this season's fresh burn scars, which will stay flood-primed not for weeks, but for years, because hydrophobic soil and dead root systems do not repair on a news cycle. This rung is strange to place on a worst-case ladder because it doubles as the dome's most likely natural death, and that is exactly the point. Even the good ending has a bill attached. There is no path off this board where the Southwest simply wakes up one morning unharmed. The choice on offer is which harm, at what speed, with how much warning. Now zoom all the way out, because the topmost view belongs in the answer too. This dome is one expression of a hemisphere-wide pattern this channel has tracked all summer. The same locked, wavy jet stream configuration that has been running Europe's heat and rearranging the Pacific storm basins, all of it riding on an El Niño and the warmest ocean baseline in the instrumental record. We covered the ocean half of that machine yesterday. The point, for today, is that the dome is not an isolated malfunction. It is the North American face of a planetary summer, which is part of why the exits look so narrow. The pattern that would need to change is bigger than the continent. But now the counterweight, stated with the same care as the dread, because this channel deals in both. Domes break, every one of them, eventually, including every monster on the historical ledger. The 1936 wave broke. Chicago's broke after a week. The 2021 Northwest Dome, the most intense of them all, collapsed within days of its peak. There are 3 exits, and all 3 are physically live. The eastern trough could amplify and shove the ridge west and off its moorings, and the models are already split on exactly how hard that trough digs, which is the crack of daylight we flagged in Act 1. The monsoon could surge, Rung 5's costly mercy, or the seasonal clock itself intervenes, because late August shortening days slowly drain the solar income every dome runs on. Persistence is a forecast, not a law of nature. The reason this video exists is that, for the first time in this dome's life, the official forecast has stopped containing its ending, and the gap between a dome that breaks in 5 days and one that holds for 25 is, as the ladder shows, the gap between a hot news week and a national catastrophe. Every rung on that ladder is a duration function. None of them requires anything unprecedented. That is the answer to the title, and it is also, not coincidentally, the reason a certain family of theories catches fire every time a dome like this parks over the country. Because when people are told that nothing unprecedented is happening and simultaneously watch records fall out of the sky, some of them conclude that somebody, somewhere, must be lying. So before the watch list, let us do what we always do here. Take the theories seriously enough to test them. Part 13. The Kernel and the Debunk. Whenever a heat dome parks over America, a familiar set of explanations blooms across social media in its shade, and this channel's standing policy is to treat them as questions rather than punchlines, because buried inside almost every viral theory is a kernel of something true, and the kernel is usually more interesting than the conspiracy wrapped around it. It is worth pausing on why heat specifically breeds these theories so reliably. A hurricane has a shape, a track, an arrival time. An earthquake has an epicenter, a heat dome has none of that. It is invisible, it has no edges you can film, it announces itself only through numbers on screens, and it behaves with what feels like intent, sitting motionless over one region for weeks while the rest of the map moves normally. Human pattern detection hates that combination. We are wired to see agency and persistence, and a thing that will not leave feels scent. So when the theories arrive, they deserve a real hearing, because the instinct generating them is not stupidity. It is a reasonable brain demanding a mechanism. The job of a channel like this one is to supply the actual mechanism and then check whether anything is left over for the theory to explain. So let us do exactly that, theory by theory. Theory 1 is the perennial. The dome is engineered, steered into place by weather modification programs, by atmospheric heaters, by whatever acronym is trending. The kernel of truth is that weather modification genuinely exists. Cloud seeding is real, operational and practiced across the West, and it is entirely reasonable for people who learn that fact to wonder how far it scales. The test is the energy budget, and the theory fails it by a margin that is difficult to overstate. Cloud seeding nudges precipitation from clouds that already exist, using grams of silver iodide and the atmosphere's own stored energy. A continental heat dome involves reorganizing the thermal structure of the atmosphere across millions of square miles, a structure whose energy content dwarfs the combined output of human civilization by orders of magnitude. No facility on Earth operates within screaming distance of that scale, and there is a quieter tell. This dome was forecast publicly days in advance by physics-based models running on open data, and it has evolved almost exactly as those models predicted, which is precisely what an engineered anomaly would not do. The models know nothing about secret programs. They know thermodynamics, and thermodynamics has been sufficient. Theory 2 is this week's special, and it deserves the most respect because its kernel is not just true, but circulating inside the mainstream coverage of this exact event. The claim is that the records are manufactured, that airport thermometers are rigged or badly sighted, that Sky Harbour's 117 is an artifact of a sensor parked on a griddle of tarmac. And the honest part is real. Local reporting on this very record noted that airport readings can run roughly 4 to 6 degrees hotter than some surrounding neighbourhoods. Sensor sighting genuinely matters. Airports genuinely are large, dark, flat surfaces. The urban heat island is not a conspiracy theory. It is a measured phenomenon this channel discusses constantly, and a Phoenix suburbanite whose backyard thermometer read 111 while the news said 117 is not hallucinating the difference. But walk the logic carefully, because this is one of those cases where the skeptical instinct is aimed at the wrong target. A record is not a claim that the whole city experienced 117. A record is a comparison of one station against that same station's own history. Sky Harbour's 2026 competes against Sky Harbour's 1990, and Sky Harbour's 2023, same site, same surface, same sighting biases, decade after decade. If the airport runs hot today, it ran hot when every previous record was set there too. The bias, whatever its size, subtracts out of the comparison. The anomaly, the thing that changed, survives. The corroboration argument closes the loop from the other side. If one rigged or badly sighted thermometer were manufacturing this event, the surrounding network would contradict it. Instead, Yuma, a separate station run through a separate office 160 miles away, posted 116 the same afternoon. El Centro, across the state line in California under yet another forecast office, posted 117. Station after independent station up and down the lower Colorado River Valley cleared 115 in the same hours. A sighting flaw is a local defect. It cannot synchronize itself across 3 states, 2 regional offices, and dozens of instruments maintained by different hands. And if you want the single cleanest rebuttal of all, it is the record this video has been built around, the 97-degree overnight low. At 4:25 in the morning, there is no sun heating any runway anywhere. The tarmac argument is an argument about afternoons. The record that matters most, the one tied to the deadliest mechanism in the medical literature, was set in the dark, and no sighting theory touches it. Theory 3 says the grid's fragility is being hidden from the public, that officials know how close the system runs to the edge and keep it quiet. The kernel is that utilities do not, as a rule, lead their press releases with worst-case mortality modelling, and that the Stone Studies numbers received a fraction of the coverage the daily temperature graphics get. But hidden is simply the wrong word for a scenario that is published in a peer-reviewed journal, reported in the national press, and co-authored by the sitting director of Phoenix's own heat office. The information is public in every meaningful sense. What it is ignored, under-discussed relative to its stakes, and that is a real civic failure worth being angry about. It is just the opposite of a cover-up. The warning is sitting in the open, doing what unheeded warnings do. Theory 4 comes from the other direction, and intellectual honesty demands it get the same treatment. It is just summer, this crowd says. Phoenix is a desert. It has always been brutally hot, and turning a hot week in a hot city into a crisis is theatre. The kernel here is genuinely substantial. Phoenix in July is savage every single year. Single hot days prove nothing, and a media environment that treats every warm afternoon as an apocalypse has done real damage to public trust. If you feel that fatigue, this channel does not think you are foolish. The reply is not outrage, it is arithmetic. 117 beat every July 24th in more than 80 years of that station's history. 97 tied the warmest night ever measured there in any month across every one of those years. The 2023 streak nearly doubled a duration record that had stood for 50 years, and the hottest month ever recorded in any American city happened in this city 3 years ago. Always hot is true, and it describes the baseline. The story is the departure from the baseline, and the departure is measured, not narrated. And for completeness, the cosmic alibi. Some will reach for the sun, as they do whenever anything on Earth misbehaves, and on this channel of all places the sun gets its hearing. Not this time. The space weather board this week is as quiet as it gets. Geomagnetic indices flat. No storms in progress or forecast beyond a possible minor brush early next week. Solar activity puttering through low levels while the sunspot count drifts down its cycle's decline. Solar output does vary, and we cover every twitch of it here, but its variation over a week is measured in fractions of a percent, orders of magnitude too small to build a continental pressure ridge, and its quietest stretch of the month has coincided with the dome's loudest. Whatever is pressing down on the southwest, it is not arriving from 93 million miles away. The machine doing this is entirely terrestrial, entirely measured, and entirely consistent with its own forecast. Notice what every tested theory has in common. Each one, pulled apart honestly, points back at the same physical object, a measured dome, behaving as the physics of measured domes dictates, over ground its own persistence has prepared. The uncomfortable truth under all the theorizing is that nothing hidden is required. The visible explanation is the alarming one, which leaves only the practical question, the one this whole video has been building toward. If the dome's future is the variable that decides everything, how do you, watching from wherever you are, actually track which future is arriving? It turns out the next 10 days come with checkpoints. Part 14, What to Watch and What Breaks First. Here is your watch list. 7 checkpoints, each one public, each one falsifiable, each one a direct reading on which branch of this story the atmosphere is choosing. Screenshot this part if you like. This is the instrument panel for the rest of the summer's biggest question, and everything on it is free. The forecast discussions live on the Weather Service's public site, office by office. The Storm Outlooks post on the Storm Prediction Center's page every morning. The Drought Monitor posts its weekly map every Thursday. Nothing in this part requires a subscription, an app, or anyone's permission. The gauges are all sitting in the open, which has been this video's quiet refrain from the start. The information was never hidden. It is just rarely assembled. Checkpoint 1, the ceiling. By late Friday, the 31st, the models say the ridge over Utah approaches 600 decameters. Watch whether the analyses actually get there. If the dome verifies at 600, it has reached a structural maximum, among the strongest ever measured over the interior west, and the persistence scenario gains weight. If the heights come in under forecast, the dome is running below its billing, and every rung of the ladder gets a little further away. One number, one date, no ambiguity. Checkpoint 2, the floor. Phoenix's overnight lows, every single morning. This is the kill mechanism's own gauge. Nights dropping into the low 90s and upper 80s mean the ratchet is slipping and the city is getting its recovery windows back. A run of our nights at 90 or above, the 2023 signature, means the template is executing, regardless of what the afternoon headlines say. The beauty of this checkpoint is that it is immune to hype in both directions. An afternoon high can be argued about, contextualized, dismissed as just Phoenix. A month of 90-plus dawns cannot. The most important number in the southwest for the next month is published every day before sunrise, and almost nobody looks at it. Be one of the people who does. Checkpoint 3, the alarm count. The national alert total sat at 353 yesterday morning, and 431 today. Watch its trajectory over the coming week. A crest and decline means the dome's expansion phase is ending. A continued climb through the 400s means the footprint is still growing, and every alert added is another population inside the experiment. Checkpoint 4, the grid. Watch for the Southwest utilities and the Texas grid operator to report record or near-record demand as the week peaks. Demand records are the stone scenario's preconditions being assembled in public, in real time. They are also, in fairness, evidence of the system carrying its load. The checkpoint is not a record itself. It is any day where demand records and equipment trouble appear in the same news cycle. That is the combination that moves rung 3 from theory toward the table. Checkpoint 5, the ground. Thursday morning, the drought monitor updates, built from data closed out each Tuesday. The severe drought number has been parked at 29.14%. If the coming updates hold that plateau, The feedback loop is merely sustaining itself. If the number starts climbing again under the dome, the loop is winning. The ground is drying into better fuel for both the ridge and the fires, and the dome's own life support is strengthening. Checkpoint 6, the rim. Today's South Dakota window and Sundays across the upper Midwest. Whether tonight's storms organise into that forecast wind machine, and whether Sunday night's round grows into the swathe the Outlook sketches, tells you how much energy the dome is exporting to its edges. The rim is the dome's fuel gauge, readable from any radar app in the country, and Checkpoint 7, the one that answers the title, the August test. The federal extended forecast currently carries this heat through the 1st of August. Somewhere in the next week to 10 days, the models will commit. Either the eastern trough digs hard enough to crack the ridge, the monsoon surges into its core, and the first week of August arrives as the dome's obituary, or the guidance extends again into the second week of August, and the 2026 dome formally enters the calendar territory where the 2023 template did its worst work. There is even a specific tell to listen for. The extended discussions have already flagged the East Coast trough as the model's main disagreement, with some guidance digging it harder than the rest. When those discussions start using phrases like ridge suppressed, ridge retrogrades, or heights falling over the Great Basin, that is the sound of the exit opening. As long as they keep writing ridge remains dominant, the experiment is still running. Watch the phrase heat continues in those outlooks, the way you would watch a gauge on a dam. That is the panel. And knowing what to watch, you also know the honest answer to what breaks first. Because it is a race with 3 runners. The pattern can break first through any of the 3 exits, the trough, the monsoon, the season, and if it does, this video becomes the record of a near miss, which is the outcome to root for. It has happened before, more often than not in fact, because most strong domes do break before their worst case matures, and honesty requires saying that the base rate favourite in this race is still the pattern. The records break first if the pattern holds even a week, and that is survivable. Records are only numbers, right up until they are the floor the next afternoon launches from. Or the systems break first, a grid segment, a fire line, a human body's limit multiplied across a county, and that is the outcome the whole ladder climbs toward, the one whose price the ledger already lists in certified names. 3 runners, 1 finish line, and the gap between them measured in exactly the units this whole video has been about. Days. Nothing but days. One more honest note belongs on the panel before we close, about the people whose job this race is. Somewhere in every forecast office under this dome, meteorologists have spent this week writing warning texts they know most people will never read, staffing overnight shifts through the same unrecovered nights as everyone else, and trying to compress a duration threat into products built for events with edges. The quality of this country's heat warnings has climbed enormously since Chicago, precisely because that disaster taught the service to warn on nights and duration rather than afternoon peaks alone. If the 2026 dome ends as a near miss, some real share of the credit will belong to warnings that landed in time, checked on neighbours, and cooling centres that opened before the queue formed. Systems are not only things that break, sometimes they are things that hold, and which one this summer becomes is not entirely up to the atmosphere. The dome does not know any of this. It is not malicious, not aimed, not sent. It is a self-reinforcing arrangement of pressure and heat, running an experiment it did not design on a civilization that mostly is not watching the gauges. And there is something almost vertiginous in how ordinary its ingredients are. Sinking air, dry ground, sunshine. Nothing in this entire video required exotic physics, and that is the part worth carrying with you, because it means the difference between the summer that passes into trivia and the summer that enters the ledger is not made of anything rare. It is made of arithmetic, compounding quietly, night after 97-degree night, in the one column nobody screenshots. The body recovers at night, the grid recovers at night, the pattern only ever breaks from outside. Of everything under this dome, only the human attention span resets every morning, and the one variable this video can actually change is whether yours does. So here is the thread to hold. Sometime in the next 10 days, the extended forecast either writes this dome's obituary or extends its lease into the second week of August, the exact window where the deadliest summer in modern American urban history ran its endgame 3 years ago, in the same city that just spent a full night above 97 degrees. One paragraph of forecast prose, issued from a quiet office in Maryland, will tip this story toward near miss or toward ledger. We will be reading it the morning it posts. Make sure you are here when we do.